Okay, so Junior Roberts here with realjuniorroberts.com. In this video, we'll be looking at physics multiple choice questions, specifically under the topic of mechanics. So let's go right into this. Okay, so our first question here says, which of the following groups of quantities contain one which is not an SI-based quantity? And we have our responses here. A as mass, length and time. B current, temperature and length. C volume, temperature and time. And D as time, mass and temperature. So looking at these, we should be able to, from our knowledge of SI based quantities, we should be able to determine which of these as quantities that is not a SI based quantity. Our 5 SI based quantities are mass, length, time, temperature, and electric current. Right? So, sorry for the poor handwriting. Now, essentially, if you look at these lists right here, we see that volume is present right here, and volume is not one of our list of 5 SI-based quantities. So therefore, our answer to this question will be C. Right? So our answer for this question will be C. Let's move on. So this question says a piece of string is tied onto a small stone, and the stone is then totally immersed in water. The tension in the string will be, and our answers are 0, equal to the weight of the stone, less than the weight of the stone, and more than the weight of the stone. So if we were to sketch out the situation here, let us say we have a container and there's some water in there, and then we have a stone attached to a string, and the stone is submerged in the water. So this is the stone here, and it is submerged in water. Now the question wants us to state what will happen to the tension of the string. So if you think about this question here, the tension in this string will be due to the weight of this stone here. Now, when the stone is placed in the water, there will be an upward force, right? Now, the weight, first of all, the weight always acts down. So the weight of the stone, let's call it WS. Weight of the stone will act downward. And then there will be an upward force due to this water here, and we call that the upthrust. Right? Upthrust from Archimedes' principle. Now, since there's an upward force counteracting the weight of the stone, and again, the weight of the stone will be equal to the tension in the string. So, since there's an upward force counteracting the tension or the weight of the stone, it means then that the tension of the string will be less than the weight of the stone. Right? So, answer here will be C. Because again, what we're saying is that the tension T in the string, when it is in air, is equal to the weight of the stone. Now, when the stone is placed in the water, because of this upward force, the weight of the stone will appear to be less due to this upward force. So therefore, the tension will be less than the weight of the stone. So our next question says, the relative density of brass is 8.4. Which of the following is the best statement that can be made? Right? So we have our options. Brass is heavier than water. Water is heavier than brass. Right? 100 centimeter cube of brass is heavier than 100 centimeter cube of water. And 100 centimeter cube of water is heavier than 100 centimeter cube of brass. Now, before we answer this question, we first need to recall our definition for density. Right? So we know that density is simply the mass divided by the volume, right? Or the mass per unit volume of an object. And relative density, on the other hand, now is the density of any substance, in this case, brass. So the relative density of brass will be the density of brass compared to the density of water. Now, again, since density is mass per unit volume, it means then that we have to consider how much mass is in a certain volume. Now, in this case, if we look at these two, A and B, these two will be totally out of it, right? So we can narrow down our responses or our answer to these two here. Now, since the value for the relative density is 8.4, right, it means then that the brass will sink in water, right? So we can say that 100 centimeter cube of brass is heavier than 100 centimeter cube of water. So our answer here will be C. All right, let's move on. Now this question here says, a glass marble X moving with a velocity of 6 meters per second collides head-on with an identical stationary glass marble. What is the velocity of Y after collision, assuming X is brought to rest? Okay, so if we sketch out this scenario here, we will have something looking like this, where we have our marble X, right, moving with a velocity of 6 meters per second, and we have marble Y, which is stationary, right, so it has 0 meters per second. Now, since there are two identical marbles, we're gonna call their mass M, right, M and M. Now, what the question here says happen is that when marble X collides with marble Y, marble X remains stationary and marble Y moves off with a certain velocity. So if we think back to the concept of collisions, this would be an example of an elastic collision, right? A perfectly elastic collision. So therefore, two things will be conserved. Momentum will be conserved, and also kinetic energy will be conserved. Now, since we know that kinetic energy is equal to half mv squared, and we're saying that the kinetic energy before is equal to the kinetic energy afterwards. Now, since the two marbles are of identical mass, right, and marble X was moving with a velocity of 6 meters per second, since kinetic energy will be conserved, marble Y must move off with a velocity of 6 meters per second. So our answer here will be 6 meters per second. So let's move on. Now this question here says 3.1415926 expressed to two significant figures is. Now, when we express numbers in terms of significant figures, we first of all need to pay attention to all the rules of significance. Now, the first rule of significance says that all non-zero digits are significant. So it means then that all these digits here would be significant, but the question wants us to write it as two significant figures. So we're going to start with the leftmost value, right? So this will be our first significant figure, right? This will be our second significant figure. And if we look to the following significant figure, in this case it is a 4, right? So since this is a 4, what we will do is we will keep our digit here. If this was, however, a number 5 or greater, we would have to round up this digit here. So in this case, our answer would be 3.1. Right, and again, this incidentally is the exact value of pi. Right, normally we will write pi as 3.142, right? So this is the exact value of pi. So let's move on now. Which of the following has no units? Now, we know that velocity as a unit, relative density, we're not sure about that, energy as a unit, and momentum as a unit. So therefore, our answer would be B. So this question here says, the symbol for the unit of moment of a force is, now remember that the moment of a force T is equal to the force multiplied by the perpendicular distance, right? So we know that force as unit of Newton and D as unit of meters. So therefore, the unit for the moment of a force is B Newton meters. Now, this question here says, now, which of these is the unit of work? Now, we can derive the unit for work by looking at first the formula for work. So we know that work, right, is equal to the force multiplied by the displacement, right, or force multiplied by the distance moved in the direction of the force. So we'll say that work is equal to force times displacement. Now, the unit of force is a Newton, right, and the unit of displacement is the meters, right? So therefore, we can say that the unit of work can be written as Newton meters. Now this question here says, now the unit of electrical resistance is expressed as, okay, so we know from Ohm's law that V is equal to I multiplied by R, right? Where V is our potential difference, I is our current, and R is the resistance. So therefore we can write resistance as being equal to V over I, right? So taking the SI units for V and I, we can derive the SI unit for resistance. So the SI unit for V is, our potential difference is the volts, V, and that of current is the ampere, A, right? So we can write then that the unit for electrical resistance will be equal to volts per ampere. So therefore our answer will be the volts per ampere, which is A. Now this question here says, now the time period of a simple pendulum oscillating with a small amplitude depends on the mass of the pendulum bob, amplitude of the oscillation, the length of the pendulum, or the force with which the pendulum is set in motion. Now, for a simple pendulum, there are two things that affects the period of oscillation. Number one is the acceleration due to gravity, and number two is the length of the pendulum. So therefore, our answer in this case will be the length of the pendulum. Now, this question says, a book of weight 12 Newton is resting on a table. The force that the table exerts on the book is, okay, so let me do a sketch of this scenario. So let us say I have a table here, right, and there's a book on that table. So this is the book on the table, right, and they said that the weight of the book is 12 Newton. So therefore, there will be a force of 12 Newton acting down on the table. Now, since the book is not accelerating, there is an equal and opposite force that is acting on the book, right, and that force is due to the table. So therefore, we will have an upward force like this of 12 Newton acting on the book, right? So therefore, the table, and again, the table is what exerts this force here, and it will be 12 Newtons. So the answer here will be B. This question here says, a particle moving with a constant speed in a circular path as. So first of all, this question here is quite interesting. So let us say we have an object moving around a circular path like this, right? So we want to know what happens to this object as it moves around the circular path. So if we look at our responses, A says constant velocity, B constant acceleration along the radius of the path, B variable acceleration, or D constant acceleration tangential to its path. Now the answer to this question here is D, right? And the reason for that is, let us say we have an object moving around this path here. When the object is right here, let us say we have a cardinal points here, north, south, east, and west, right? So let us say the object is right here, right, and it's moving. Object is right here. Object is right here, and it is moving in a clockwise direction. So let us say it's moving like that, right? So when the object is at X, it will be moving towards the west, right? It will want to go towards the west. So its direction will be towards the west. Now, when it is right here, let us call this Y, right? It will want to move south, right? When it is right here, let us call it here Z. It will want to move towards the east. Then when it reaches right here, let us call this P. It will want to move north. So what we realize is that the direction is constantly changing, right? And since we have a change in direction, even though the speed is constant, once there's a change in direction, we have an acceleration happening. And the reason for this is as the direction changes, the velocity of the object is also changing. And since we have a change in velocity, we will have the object accelerating. Now this question here says, a bus with luggage loaded on top is more likely to tip over when rounding a corner than the same bus without the luggage. The reason for this is that the luggage raises the center of gravity of the bus. Now this question here says, a uniform rod XY of weight 40 Newton is held in equilibrium horizontally as shown in the diagram below. Which of the following is true? Right? Now this question here says that the uniform rod is held in equilibrium, right? And we know from the principle of moments that when a system is in equilibrium, the clockwise moments, right, is equal to the anti-clockwise moments, right? So the sum of the clockwise moments is equal to the sum of the anti-clockwise moments about the same point, right? So in this case, our two moments is T1 and T2. T1 will be our clockwise moment and T2 will be our anti-clockwise moment. So again, so since the system is in equilibrium, it means then that our two moments, one clockwise and one anti-clockwise, will be equal. So our answer is C. Now this question here says, which of the following is used to calculate the efficiency of a machine? Right? So the answer for this question here is load times distance moved by load over the effort times the distance moved by the effort. So our answer is B.